Hello, if you're watching this video sometime in the future, you may find that this thing is no longer called S-Bus Mixer. That's just what we're going with at the moment. But whatever it ends up being called, this video is supposed to give an introduction as to what it's all about. This is the third of the prototypes that I've been working with, but just before I get into the details any further, I want to take a step back and describe this whole thing a little bit more generally, because if you've been watching my videos over the last couple of years, you've probably seen these and you have kind of a rough idea of what they might be all about. But I want this video to serve as a more general overview for somebody who has no idea. So if I had to come up with as concise a description of this as possible, like an elevator pitch, as they say, it would probably look something like this. I say Arduino-like because there's probably quite a large overlap between the kinds of projects that people would make with this and the kinds of things that people do with Arduinos. I say strong focus on RC-related features because that's mostly what I've been using it for, and as such it includes the S-Bus protocol and iBus protocol, and also NRF24 modules, those little wireless modules, so not necessarily controlling a vehicle, but just general wireless communication can be done as well. Configured by Visual Editor rather than source code. I hope you know what source code is, but Visual Editor looks, in this case, kind of like that. And just in case you didn't know, source code looks kind of like that. Regarding the use of a visual editor, I've listed up some pros and cons here, and I'll just let you pause the video if you want to read those. But basically what it comes down to is that it's heavily skewed in favor of beginners. So if you don't know anything about writing source code and you don't care, you don't want to learn, you just want to get something up and running quickly, this is a great way to do it. The biggest con is the first one that I've listed there. So it depends on what you're making. If you're making something that's within the capabilities of the system, then even a hardcore programming nerd like me might find this a quick, easy way to get something up and running that's good enough. Just to give some background on how this project got started and why it became known as the S-Bus Mixer, even though I've said many times I don't really like that name. Back in early 2020, I was building the farm hopper, which was going to be a plane with 9 servos and 1 motor, so that's 10 outputs, and I wanted to have a fancy mixing on the servos so that I could do differential aileron, and I wanted the flaps to move with the ailerons and stuff like that, and I wanted to control this with an Omnibus F4 Pro running ArduPilot so that I could have fly-by-wire A and return to launch and all that cool stuff. And the trouble was how to get this to happen, because the Omnibus F4 Pro only has 4 outputs. But I discovered that one of these outputs can be set to be S-Bus, and most importantly, it's S-Bus that already has the autopilot functions in it, so it's going to do your return to launch and that kind of stuff. So looking at this, I mean, what else are you going to call it? Anyway, I got the prototype made and I tried that out in the farm hopper. It seemed to work out all right. And Spike from FPV Reviews, who some of you may know, asked me if he could get one to try it out, and I said, yeah, sure. But then I realized that every little setting, including like servo travel, the center points, the mixing, everything was hard-coded in source code. And I thought, that's a pretty horrible way to give this to somebody else to try and use. So I started to think about ways to make a configurator. And I'm not exactly sure when the idea came up to do this visual editor thing, but the more I thought about it, the more it dawned on me how much potential this had if it was made into a more generic system. And thus began the feature creep. So I spent the next couple of years adding more and more features and trying to make the system easy to use, keeping in mind that this would probably be aimed at beginners. And along the way, I redesigned the board a couple of times as well, and ended up moving to a larger processor, well, one with more memory and more pins, not necessarily faster. So this is how the board's laid out at the moment. I would, of course, like to have made a few more iterations on this, but right about the time I started doing this, the price of these chips got crazy expensive, which was very annoying. And the microcontroller itself, I'm already starting to run into the limits of how much program space this one has available. So this might change to an RD or an RE even in the future. But for the most part, I'm happy with everything here. The size of this particular board is a little bit larger than you might be used to. This is 5 centimeters square. So typically your flight controller that you have for mini quads or whatever, that's about 3 centimeters or 36 millimeters. So this is a little bit on the big side compared to that sort of thing. But the main reason is that I wanted to use as many pins as I possibly could for this first version to just check everything's going to work. And then maybe in the future a smaller version could be made that doesn't have such an excessively large number of pins where it's not necessary. Anyway, so just to look at the components, we have the microcontroller, MPU 6050 gyro and accelerometer, micro USB connection, and there's a 2 megabyte flash memory, and this is where your program is going to be stored. So when you upload a program, as we'll see in a minute, it doesn't go on here, it gets stored into there. So this is kind of functions like a hard disk in a way on your desktop computer. And in a way, the thing that I've made, I don't know if you could call it an operating system or a virtual machine or whatever, but it's sort of somewhere in that region. But anyway, your programs can be stored on there, so that's an integral part of the system. We have an I2C header there and a mini display header. I'll show you how this works in a minute. And NRF24 shaped header there. And then we have some RGB LEDs there, so those are the addressable ones. These are the inputs that are supported at the moment, and I don't want this video to get too long, so I'll just let you pause this and look at these in your own time. Although I will just mention here, what does up to 37 mean? This just means that there are 37 pins available for digital input, as long as those pins are not being used for something else. So for example, pins 1 and 2 here, we can see that these are the pins that would be used by UART1. So if you're using UART1 for something, then obviously these pins 1 and 2, you can't use those for digital input. So that's what all these up to labels mean along there. And these are the outputs that are supported at the current time. And again, I'll just let you pause the video and look at that at your leisure. Now, that hardware board is obviously only one part of the system. We also need some way to configure this thing. And that is done by plugging it into a computer with a USB cable and using a web browser to set it up. But unfortunately, the web browser is not allowed to talk to a COM port or a serial device directly. So we need something in between to let them communicate with each other. And we have this thing called a relay server. I've called it relay server because it doesn't really do anything other than just pass information between these two things. And this relay server will need to be on the same computer that the USB plug is connected to for the device. But interestingly, on the other side, the web browser does not need to be on the same computer. So I didn't really plan that in on purpose, but it turns out to have some interesting possibilities. For example, the web browser doing the configuration could and potentially be on the other side of the world as long as you have an internet connection between the two. And as far as browser compatibility goes, I've tested on Chrome and Firefox, Safari and Edge, mostly on Chrome admittedly, but I have done a decent amount of testing on the others. I also tried it on Opera, which I think from memory, it's been a while ago, but I think that was okay, and probably a bunch of other browsers will be alright as well. The relay server runs on Linux, Windows and Mac, and also Raspberry Pi. And conveniently for me, that's the only thing that needs to be cross-platform, and I've deliberately made that have no graphical component. It's just a command line interface, so you don't really look at it while it's running, but it needs to be running in order for things to work. Okay, let's have a look at this configurator interface, and I'll just give you a very broad overview of how it works. It's based around these things that I'm calling nodes, and we have a big list of nodes there. And by clicking on the things in this list, we can add them into the scene or the main area there. And you'll see that some of them have an incoming arrow and some of them have an outgoing arrow. And this is just to signify that they have some sort of interaction with something outside the system, like an external device. There are also nodes that don't have any inputs or outputs directly like that. And those ones are going to do some small piece of calculation inside the system. And we can connect these nodes together in a big network, or a small network, I suppose, to do something interesting. So if I click on this one here, we can edit the properties of that. And let's say that we want to do something very simple. We're just going to add two numbers together. I won't insult you by doing 1 plus 1. Let's go 2 plus 5. So that's going to give us the number 7. So you could consider that the number 7 is sitting here on this little dot as the output, waiting to be used by some other node. So we could put another node over here, and then the input, this will be taken as input for that one. And so this will add another 5, and so we'll get 2 plus 5 plus 5, and this little dot here will now be a 12. I hope that makes sense. The output value for these nodes is typically a number, like the case that we just did, but it can also be a color. For example, if you wanted to control some of those RGB LEDs, you would do it like this. You would have a RGB LED node, and you say which LEDs in that string should be lit up, and then you would choose here what color you want them to be. So it can be a color, but like I say, it's typically a number, and it's a floating point number, but we could also interpret that as a Boolean depending on whether it's greater or less than 0.5. That's the tipping point where we decide whether it's true or false. So as an example of something that I was doing not long ago, I was using a barometer that has a very good temperature sensor in it actually, and I was wanting to see whether something was 10 degrees or greater. So I did this, and then I did this, like that. Right, so now we have something that looks a bit more sensible as a Boolean value, because the greater than operator that we're using now, this is a true false question that we're asking. So the value now on this output is going to be either a 0 or a 1. And then we could use that for something else inside the system, or as in the case where I was doing recently, I would just take it straight out to a digital output, because that's all I needed to do. And then you need to say what pin that's on. Let's say pin 14. So that's a pretty simple case of something that you might actually find yourself doing. And then this whole network of nodes is going to be executed 50 times per second over and over and over, 50 hertz. I haven't really found that it needs to go much faster than that, although there was one case that I did want it to go faster. So I think in the future I might make it possibility to also select 100 hertz or 200 hertz, for example. But for the time being, it's just 50 hertz, and that seems to be fine. All right, let's try connecting the actual device, and we'll see how that works. But remember, we can't just connect the USB here and expect the browser to be able to talk to this device directly. We need that relay server in the middle to let them communicate. So I'm just going to run the relay server directly from a terminal like this. This is how I've been doing it quite often. You could put this into a service, I guess, on Windows and make it so that you don't really need to start it all the time, because once we've started it like that, we don't need to look at it anymore. Oh, I should have also mentioned over in the top left we have the relay server status panel showing, and that just went green. But if I'll just kill the server and restart it, so you can see that the browser is detecting that this relay server, after a second or so, has come online, so to speak, and it's ready to use. So this is running in the background, but we don't need to look at it anymore. Now that it is running though, we can connect this like we were just trying to do before, and if I could just plug that in there, we'll see that when we connect that now, a couple of things showed up here. There's the port name. On Windows this would be some kind of a COM port, I think, and then there's the name of the device, the version of the firmware that it's running, and the available flash space that it has to use. And when we select that, it will go green, and that will let us thereafter say that this is the device that we're talking to for the rest of our configuration. Because keep in mind, there could be multiple of these here, so that's why that checkbox is there to select which one you want to talk to. And we have this toggle LED button there, which if I click that, you can see the blue LED going on and off. And this just lets me confirm that everything's connected and ready to go, and that this is the device that I'm using, and that's the actually the one that I wanted to use. You can just make sure of that. So that LED that was toggling there is number 40. There's two SMD LEDs on there. There's one called 40, one labeled 40, and one labeled 7. So we're going to use those, or use one of them anyway, for this next little bit. So what I wanted to do was a very, very simple case. We'll just have a digital output, and we'll just turn that LED on. So remember, 0 or 1 is our binary, like true false kind of a thing. So if we want to make that pin go high, we can just put a 1 in here, or anything above 0.5 basically. And pin 40 was the blue one, and then to upload that to the board, we just click upload in the top left, and that will go on. If we make this a 0, it will go off again. And the other pin that we had there, the red one was the other LED, the red one was on pin 7. So we can do this. Whoops. We can set them both to be, oh, I screwed that up. 40 and 7, sorry. Let's get that back. Right, now we upload that. All right, so both of those LEDs are on. That's probably about the simplest thing you can do with this. If you're wondering how to make a blink, blink is something that people typically do as a first program. Just hide that for a moment. So our timer just showed up there. This is probably the simplest way to make a blink. We have a timer which is just a value between, goes from 0 to 1, and over the duration of 1 second. And wrap type none means when it gets to 1, it's just going to stay there and it will stay as 1. But what we can do is set the wrap type to be wrap, which means that when it gets to 1, it will start back at 0 again. So this is going to give us a value going from 0 to 1 over time. And if we just bring my camera up again. Now if I upload this, we'll see that we have, is that 1 hertz? Yeah, I think it's 1 hertz. Should be, yeah. So those lights are just going off and on, and they're both taking the same input, so that's why we're getting the same thing on both of those pins there. And the next thing that I wanted to demonstrate was that we can do a kind of a debugging of sorts where we can actually look at the values as they're running. And we do that by showing this live values thing in the top right there, and that gives us a little like a marker below each one. If I click this here now, it will turn bright green to show that it's enabled, and we can see that the value, or we can see the value of that node in real time. It updates at 10 hertz, so it's not quite as fast as you might like, but usually it's adequate. And we can turn all these on here too, so we can see all of these, and you can see that the digital outputs are oscillating between a 0 and a 1, as we saw before by them turning off and on. Yeah, so that's how you can see what's going on. That's very useful. Another thing you can do, which is not quite so useful, is you can actually pause this whole execution in the middle of it. So I just stopped this at 0.76. So if we look at our camera, we should expect to see those LEDs are on. And then if I step, oops, let me just move that over a bit so we can see what the value is. If I step through this, it's going to step at 0.02. Well, it's 50 hertz, so every time I click this, we're moving a 50th of a second through. When we get to 1, it's going to wrap back to 0, and those LEDs should go off. Or after this, like that. Yeah, so this is just kind of like stepping through the program one loop or one iteration at a time. Another thing that's super useful is to be able to pull the configuration back off the device once it's uploaded. In order to do that, we need to upload and save. So you'll see that there's an upload and then there's an upload and save. These are a little bit different in that the upload doesn't actually write the program onto the little hard disk thingy there, the flash, SPI flash. It just writes it into the main CPU and lets it run, but it doesn't change anything on here permanently. If you want to change permanently, you have to do upload and save. The reason these are separated is because you might not always want to actually change the program. You might just want to try something without changing it. The other reason not to save all the time is that saving is a little bit slow. It won't be slow for this one because there's only, what have we got, 3 nodes here. That's not really much. But you'll notice when I click this, it will take a little bit of time. So just a second or so there. But as the program gets larger, that can slow things down quite a bit. So while you're developing, you probably just want to do upload only, and then when you've finished and got everything sorted out, you would do upload and save. But the point of that, though, now is that now that it is saved onto the device, we can power the device down. This camera thing's a nuisance, isn't it? And we can get rid of this completely so that all of our carefully prepared information is gone. And plug this back in. And then, whoops, we need the, this page here is a little bit sort of debugging stuff at the moment. I'll have to tidy that up. But you can see that our program is running on there still. So that was saved, even though we depowered it just to make sure. Let's do that again. Like that. And then we can import config from device. So if we click this, now I have these nodes stuck to my mouse, and if I click here, I'll just place them into the scene. So what that means is you essentially have the source code of the program that's running on there available to re-edit anytime you like. So all these values that we put in there will be there. The only thing you lose is that if you've named these nodes, you can give these names, give these nodes a name, like a nice name. So I can give these a name to make them a little bit easier to understand. Those names will not be saved, but the actual program itself will be saved and ready to use again. Another thing that's super useful is the ability to inject live values while the program is running. And we do that with these nodes down here called tweak color and tweak number. So if we, instead of using a timer, I'll just get rid of that, and I'll put a tweak number in here, like this. Right, so this is connected to our two LEDs, and by clicking this little bit here, we can have a slider to change the value. So I'll just put the slider down the bottom and open my camera again. And as I drag this now, you'll see that the program is directly taking the inputs as I move this slider. So when I go above 0.5, or is it, yeah, above 0.5, the LEDs will turn on. This can be super helpful for setting things like servo travel for your ailerons or your control surfaces on a plane and the center points and so on. And we also have a tweak color. We don't really have any colors with these LEDs, or not variable colors, at least they're just fixed colors. But let me just put a tweak color in here. Oops, it's gone under there. And we'll light up some of those LEDs, and we'll go with LEDs. Well, let's do them all, right? We've got 1 to 3, and this color here. Where am I going to put this? Let's put it down the bottom again. Let me just shuffle this around. Now, I'll need to do one upload because this node here is not present on the device yet. So let me just make it present. Upload. Okay, that's a bit bright, but that's what our tweak node is for here. So we'll go like this, and we can. I'm going to have to turn this down a bit because they don't show up very well on the camera if they're so bright. But anyway, you should be able to see there that they are changing colors in real time. And this is also super useful if you're trying to simulate things like a certain color of, I don't know, a certain color of lights for your models or dioramas or something like that. Another thing I wanted to show you was the bootloader, and because this system is supposed to be aimed at newbies, I wanted to make this as simple to use as possible. I'm still maybe going to change this a little bit, but the way it works at the moment is we have this firmware panel or panel type down there, and we have a list of files that we can choose from. At the moment, this is just going to look in the same folder as the relay server is running from. But the way it works is, at the moment, we're running the app or the main program itself. Let me just restart this so that we can be absolutely clear about what's happening. Okay, so we have our program running there with those two LEDs flashing. And over here we have a green display saying that we're running SBus Mixer version 1, blah, blah. But what we can do here is request a bootloader on restart. At the moment that's set to no, but if we click here it will change to yes. And then when we power this down and power it up again, we'll notice that it's a little bit different. The LEDs are not doing what they were doing before. We have this sort of two flashes going on the blue LED. And over here it's now in blue and it says SBus Mixer bootloader. And then we can select the file that we want to flash and click flash firmware there. And it will do this erase, write, verify sequence like that. It's 150 kilobytes at the moment that this is writing. So that's what I was saying earlier about sort of starting to get to the point where I'm thinking about maybe using a larger memory space microcontroller for this. Anyway, that's the firmware flash there. It's actually not going to do anything different because the firmware that we just flashed is the one that was on there anyway. But when we repower that or power cycle that again, we'll see that we're back to well, it's just doing what it did before because, like I said, we didn't actually change anything. It's still the version 1. But anyway, that's what I'm hoping there is that that's a fairly easy process for updating the firmware. Another cool feature that I added just recently is the ability to emulate a USB gamepad input. So if you look over in the top left, we have a panel called gamepad, and in there's a select option where we can say that the device should be a virtual COM port, which is like a serial connection that we've been using to communicate with the relay server so far, or it should be a COM port and a gamepad, in other words a USB composite device, or it should be just a gamepad. And you would switch between those modes by selecting the one you want and clicking this button, and then power cycling the device to get it into the mode that you want. And just to make sure first that we all know what I mean by gamepad, it's just one of these things. And if I plug this in, keep an eye on the left hand side. Thanks to the HTML5 gamepad library, it makes it very easy to just quickly check what this gamepad is doing. We've got buttons and axes there, so hopefully you're all familiar with that kind of thing. I'll just unplug that. And this S-Bus mixer here I have set up to be this option there, VCP plus gamepad. So it's going to do both. And the only thing that's really connected to it here is this little FlySky receiver, which has an iBus output there, like that. And I've been using this with my FlySky radio transmitter to play flight simulators lately. It works quite well. So if I plug this in, we'll see again on the left we have a gamepad, and on the right hand side we also have the virtual COM port here. So if I click this, then we can do all the other stuff that we were doing already at the same time as it's running the gamepad, which is pretty neat. So if I turn my radio on now and I fiddle with the axes like that, you'll see on the left hand side my switches and axes are doing stuff there, and because we have the COM port available, we can modify that configuration while it's running, or we can look at it at least. So I'm just going to do import config from device like that, just to show you what that config looks like. It's just it's pretty straightforward. It's just taking each one of those iBus channels and just putting it straight through to either a gamepad axis or a gamepad button. So we've got just the two buttons there, and this makes it very easy to fiddle around. Like, you know, you could switch those axes like that if you had them the wrong way around, or you can even do tweaking. So let's have a look at my tweak number. So in real time you can, I'll just go like this, and now when I go like that, if you look over on the left hand side, you'll see that the axis 1 there is moving in real time. So this is actually the gamepad input coming into the computer. It's kind of weird. It's going from this configurator over the COM port connection here, and then it's coming back into the computer through the gamepad on that side. I hope that makes sense. But yeah, it makes everything quite easy to set up and, you know, tweak and twiddle and get the numbers right. And you can of course use any of these other nodes as input, so it opens up fairly interesting possibilities to use your gamepad for mostly flight sims. I think this kind of thing will be useful for. You can make all kinds of inputs, and you can do neat things like changing a momentary switch into a toggle switch and stuff like that with a little bit of extra, you know, nodes in between. Obviously what I've done here is pretty simple. I'm just passing it directly straight through, but you could add things like expo and change the endpoints and stuff like that. Anyway, I think you get the idea. Another cool thing we can do is make the values of these nodes, the live values, available to a web page. Now obviously this thing that we're looking at right now is a web page already, but what I mean is you could make it available to your own custom web page that you've made. So just to remind you what a live value is, it's when we turn this thing on here, and for example this one here is my roll, whoops, turn my radio on again. So this is the roll axis on my radio control transmitter. The value is changing live in real time. So that's what I mean by live value, and we can turn it off and on here like that. So you'll need to know a little bit of JavaScript to do this. I'll just show you a very minimal example. This section here on the page, relay service status, this is made by a little bit of JavaScript that you would include in your page that I've already written. And then the bit down the bottom is something that you might want to do yourself. So I'll just show you the source code for this page, and we have standard jQuery included there. The relay server.js is the little section of page that we just saw, and then display.js is where you would put your own custom code to do something. So I'll just click on that one, and we'll see, I won't really go through this, but there's a couple of functions that you would use. The main ones is this one here, set live value enabled, and that takes a node ID. And basically what that does is the same thing as you get when you click on here to enable or disable one of those nodes. And then we have a function called on new live value reported. So this is going to give you a value from the relay server in real time to tell you what the value of each one of those nodes is. So if we just check what the ID of that node is there, so that's 27, and we'll do another one too. So 27 and 28 should be my roll and pitch axes. And if I come over here and put a 27 in here and enable, and a 28, let's do that as well. Enable. So we've got two values there, and if I remove my roll and pitch stick there, we'll see that those are being fed into this web page in real time. So I'll just leave it up to your imagination, you JavaScript programmers or web programmers out there, what you could do with this potentially to feed in the live values from your gizmos and gadgets that you might want to make and do something interesting with that. I was just about to show you another cool feature, but I didn't want this video to go much longer than a half an hour, and I think we're pretty much there already, so I'll just do this very quickly. It's called Diagnostic, and you can see here that when I mouse over this area, it's showing me some problems, like there's a conflicting pin number that's going to use pin 14, but this is also going to use pin 14, so there's a problem there. So it's almost like a static analysis, you might say, for source code equivalent. These nodes have the same name, for example, and I haven't really finished this yet. There's a whole lot more checks that could be done just to let you know that something's a problem before you even try and run your configuration for real. And over here on this tab, or this button, we have also the pin assignment. So this just lists up which pin should be connected to what external device. So for example, if you give your program to a friend, they might not really care about all this careful setup that you've done in here, but they do still need to know what they should be plugging things into here. So this is just a quick list to let you know what those are. And this one in red here is again, well, that's just what I was saying about that conflict. Pin 14 is conflicting between those two outputs there. So I think I'll have to start wrapping up this video now. I did want to include a whole lot more examples of using the various node types, but for the time being I'll just leave you with this playlist that I've been making over the last couple of years, where I've added a new feature. Sometimes I've made a video to show a proof of concept experiment kind of a thing, so I'll put a link to this in the description. Now, last but not least, I need to mention that I'm planning for this to be a commercial project. Over the years I have given away lots of source code and done tutorials and stuff like that. But I've just put way too much time and effort into this not to get something back from it. So at first you might be thinking that I'm planning to sell those boards and, you know, put the firmware on them and ship them out myself, which could be done, and I might do that at the beginning. But really, that's not what it's not what I'm selling. I'm selling the firmware, really, is what gives value to that board, because that board is very, very basic. I think anybody with a bit of skill could reverse engineer the hardware part of this project in like a day or two. Probably, if you're good, you could do it within a day. It's very, very basic. But to sit down and write the firmware and this configurator and everything, this whole ecosystem that surrounds it, would take you way, way longer. So that's what I'm actually selling. And I'm trying to think of a way where I could have somebody else manufacture the boards. For example, a big factory in China that can churn them out by the thousands, and they'll do a much better job of it. And it wouldn't require any physical shipping to come to my place and back out again, which is just a waste of energy and would make it more expensive. But I think I've come up with a way that we could use the relay server to validate a hardware that's been purchased somewhere else. So my website would sell you like a credit for installing the firmware on your device, on your board. You would buy it from just wherever, some place in China that wants to make them. And then my relay server would talk to the web server and consume one of those credits to unlock the firmware on your board, and then you could use it. I'm not really sure if that kind of thing has been done much, but I'm pretty sure it should be possible. So let me know what you think about that idea. And also, if you have a better idea for a name than S-Bus Mixer, let me know about that too, because I really don't like that name. I want to change it to something else, but I just can't come up with a better one at this time. Anyway, thanks for watching, and if you have any queries or questions, please let me know in the comments below, because I think this project is a little bit unique. I haven't seen anything quite like it out there. There are a few things that come sort of close with node-based programming, but not quite like this. So yeah, just be interested to hear any feedback you have. Okay, thanks. Bye.